Alright guys, so we have to break down the morphology and the Crested Gecko patterns and mutations to a different level now that we have Anthony, Jess, and Tom here. They have been doing a ton of work on genetics and the morphs, and a lot of the stuff that we thought was one way is actually a completely different way. So we're going to break it down. They're going to explain to us some of the morphs that we already know and love, and that's just going to help us understand how this genetics works and how we can pass these traits down to the animals we want to breed. Okay, so I guess the first thing that I think most people are confused of right now, and this was me a couple months ago, was just like phantom. You know, we think of a patternless animal, and we thought there was patternless, there was bicolor, there was phantom, and they're all separate things. Yeah. But you guys have pretty much figured out that it was all just one gene. Yeah. One gene, right?
Yeah. Actually, that was one of my biggest disappointments, was that I thought or wanted there to be multiple traits that were making all these different phenotypes. Yeah. And yeah, it was one.
Yeah, it's one trait with different phenotypes, making all the different expressions that, as people, we see as different things.
Right. So
the phenotypes is the
phenotype is just basically how it looks to us.
The paint job of the animal.
The paint job of the animal, yeah. So for example, with a bicolor, why does a bicolor have that different shade going down the dorsal versus like what we used to call like a patternless, which is just one solid coloration the whole way?
Yeah, it's just the dominance of a pattern coming through on those animals. Whereas you have the solid back ones that we call them patternless. Yeah. So it's just not showing the pattern. So you just have a different dominance level of pattern or a representation of it in the phenotype. So that's the only difference.
Okay. Yep. And when we talk about the phantom pinstripes, and there's obviously a degree of like, some phantoms are showing a lot more of like that shading pattern, like
you see like lateral patterning,
exactly, like,
or you see pinning and stuff like that.
Exactly. What?
So that's just we've added more traits to what. So the base form would technically be like a patternless, right? Right. It's got as little additional genetic variation in it as possible. Okay. So you get your patternless because it's maybe like a flame that has very little pattern, or it was more orange, right? So it suppressed it as much as possible. Phantom just kind of wiped it out. That's why you get the patternless. Yeah.
It's still there in the animal.
It's still genetically there in the animal.
Right.
But visually it doesn't
visually not there.
Okay.
So then you add pinstripe, right? So if you add a new gene, then you get phantom pinstripe, right? Yeah. And then you start getting quadding. And then if you add like white walls or something, then you start getting that big lateral pattern coming up, right?
Where it's phantom on top, but you could see the white coming through on the sides.
Yeah. And you even see that when you mix in, okay, so now let's get another gene to see how much that lateral and the pinning expresses. You get for Lily, for example. Exactly. And then you get a Lily phantom, right? And you know it's not a progression of Harlequin like some people think that it used to be. Yeah. Where, oh, phantom was a progression of Harlequin or something. And it's not, because obviously you see Lily phantoms, and then you make you breed a bunch of lilies. They don't all produce Lily phantom. Right. So that's why it's a recessive mutation, or how we describe it.
Now, is it like a Mendelian recessive?
Yeah. So it's a true recessive trait.
It's a true recessive trait.
You breed phantoms, you get all phantoms.
Yeah, but it's never true Mendelian because you have other factors making the phenotype.
Right.
So you have other traits. So when people go, well, is it Mendelian? If you look at it as the animal, it's not. Right. Because there's multiple traits affecting each other. The second that happens, it falls off from true Mendelian. But as a trait on its own, which never happens by itself in an animal, as a single trait.
Yeah, of course.
Yeah,
especially now.
That's where it's Mendelian.
Traits in all of them.
But its mode of inheritance is a Mendelian.
Can be described as Mendelian, correct. Yeah.
Okay.
So but now, just when you're only analyzing that one gene, yes, it behaves recessively. But when you analyze the animal, it's epistasis. There's so many different things contributing to how that paint job is formed on the animal that you can't just breed it in such simple terms anymore.
Right. Okay. Well, so at least we could get on the same page. Patternless, phantom, bicolor, all one thing. Right. Yeah. We're not. We could call it. We could call the phenotype something different, but it's one gene that makes that happen.
Right. Or you say morph. Right. Which is the same thing for phenotype.
Exactly.
If we start using phenotype.
Yeah. Which sounds smart.
It's a little better.
Our glasses on.
Right? Yeah.
So, how many hets do we have in our collection that we now label as het for phantom, and it works out? Like, we have hundreds.
Yeah, we can ID them now once you know your lines, and then you figure how recessive works. and the percentages of what comes out, depending on whether you're breeding a heterozygous or homozygous form in the pairing. It works out the same way, just like people do with axanthics. They know how it works. Right. It's the same process.
Real quick, in parentheses, with the axanthics, because the axanthics kind of behave as a phantom also, kind of like a lot of this, when you breed, you know, you have two recessive animals and you breed them together, and then at least the majority of the ones out there, the axanthics, are patternless animals that are axanthic. Is it just because are they phantom axanthics?
Yep.
Okay, there you go. Because most of them are, especially in the beginning. In the beginning, that's all we would see.
Has it, so when you start breeding it out and crossing it back, which is what was done with a lot of them, you're just passing that same set of traits back and forth. Okay. So it's very prominent. So that's what we're seeing. Okay. So people go, I want to see an axanthic, and most of them are really dark. Okay. But until you start breeding them out into different phenotypes with different traits, they're going to keep looking sort of similar right now, which is what we've seen for quite a while. Okay.
Now tigers. Are tigers, so with the tigers, is it anything, does it have to do anything with phantom? Or is it completely...
Only if you wanted to add it.
Right, of course.
Separate traits.
Okay, and the tiger is just a streak, the vertical streaks that forms on the animal?
Yep. Yep, and it's not always the vertical streaks. Other traits will push it in different places.
Right, like reverse pinning,
reverse pinning it up. Yeah, so there's different levels of dominance between pinstripe and tiger, and they start breaking, like we call brindles and things like that, where it breaks because you got vertical and horizontal patterns sort of checkerboarding it. Yep. Okay. So, yeah. So, but tiger is in every animal. Okay. Tiger is fixed in these animals.
You'll see tiger-ing. So you'll see us describing that a lot in the guide, like tigering. Okay. And it's attributed to like brindle animals, broken reticulated pattern, really soft, nice, smooth bands that go all the way across. Yeah. Flames on the lateral, like
that break between the pattern.
Okay, so
the freckling.
Yes. Yeah. So you know, initially, especially me, I thought it was like for it to be a tiger, for it to have tiger, it would have to be basically a patternless with those streaks.
Yeah. So that's where it came into the hobby at. Right. Right. So that's what we're used to, and that's what it was named after because it looks like the tiger stripes, right? Yeah. So yeah, our human perception is it looks like a tiger. So that's
you're heavy into gargs, and so we used to have a brindle and reticulated pattern, right, for both of them. Well, when they wrote the garg book, a bunch of breeders got together and they started looking at those two more specifically. And with all their data, they realized it's the same thing too. Yeah. So now, how they combined it, it's a BR morph. So the brindle or reticulated. Brindle reticulated, yeah. Or yeah. And banded reticulated, sorry, not brindle. So it's banded reticulated in that morph. So and if you
expresses differently.
Yeah, and if you've read it, I don't know if you've read it, but if you read it, they describe like each one can make one or the other. Right. And breeding them through like a line will just mean that it will form that pattern more often, more regularly.
Okay, so when you guys say that the tiger gene is in every crested gecko, how do you guys come to that conclusion? How do you know that?
So anytime you breed out your animals, because we bred so many different combinations, right? This was something we went over in the beginning, and this was sort of early on when we started talking about this. Yeah. That interaction, we had to talk about what we saw coming out of the wild types and how it progressed over time, and then we started this phantom pin. So like, we watched it progress, not just here's a phantom pin, here's a tiger, but we saw everything in between. So all the brindling, it was like a puzzle that we slowly put together and realized that the tiger was being moved around and affected. And it's through a progression of, I don't know, thousands of animals.
Yeah. It's like, have you ever produced a unicolor animal that's all just white pattern or orange pattern? Right. Like it's always got, but it's always broken in some way. right? There's always some
on
breaks.
the dorsal or on the lateral.
Wiggly
lines. Usually the vertical pattern.
Even like an all yellow animal, right? They'll still have like breaks like and little freckling and some type of pattern that's forming to break it up, right?
Yeah. Or along the lower pattern, like the mid-lateral line, you'll see it being pushed along that too, so there's sort of an outline. Yeah. Just like the reverse pin, it's the same thing. It's just being pushed both directions. Yeah. So it's the same exact thing, but you'll see both on your animal. Okay. You won't see one or the other usually.
Well, what about like certain like dark pinstripes that they have the the dorsal, but there's no, or like a super stripe, for example. Mm-hmm. Where's the tigering in that?
So on most super stripes, you'll be able to see a couple things.
Or is it just hidden, there's
a couple things happening too. So like super stripe, it's really forming the pattern like completely horizontally, right?
We're dealing with pinstripe animals.
Yeah, and so you're same thing with like pinstripe animals, right? Or quads and stuff like that. Mm-hmm. Where it is the only other gene that's working against tiger, where it's trying to, or how it orients the pattern. Right. So you're orienting.
Tiger is vertical. Mm-hmm. Pinstriping is horizontal.
Right. So it's the only one like where if you keep stacking pinstripe over generation, you'll start seeing tiger go further and further away. Mm. So when you're talking about super stripes, right, you'll start seeing it in the dorsal as well. Yeah. So super stripe is another gene that's also orienting pattern in another particular way. It's the same way as pinstripe, right? Mm-hmm. And so we have super stripes, but we also have really heavily tigered animals, right? So what does it do to our super stripes?
So with the tiger gene, because it is going this way and the pinstripe is going this way, it's what a lot of people thought was the reverse pinstripe, which is actually the pattern of the tigering being inhibited to go back downward over the laterals. Yeah,
and the dorsal.
And the dorsal, So on our super stripes, you can see when they're really clean, it's just one color in between the two stripes. That's because the pinstripe has already pushed the tiger downward. But from the super stripe part, it pushes it outward into the pinstripe, causing that thick banding of the super stripe onto the dorsal.
And shattering certain areas. Like if you have a het, for example, right? So it's less oriented to dividing up that pattern. So you start seeing shattering in the dorsal. You'll see some of it in the laterals. Like quad stripe, you'll see them sometimes they wiggle. Yeah. Right? That kind of stuff. Oh, okay. So how it's moving the pattern, massaging it around in areas.
Right.
So a lot of times whatever you see on the dorsal, it is mimicked in the lower laterals. Mm-hmm. So when you get your white walls and all that sort of stuff, you usually have a really white back. Right. And it's all white at the bottom. Right. So it mimics that. The lower laterals tend to mimic.
Okay. And then dorsal. That's going to take me to the next thing. So like with the flames, that was like the most basic morph back in the day, right?
Yeah, wild type.
And now from talking to you guys are talking about, there's orange pattern with the flames, with the markings down the back, or there's the white patterning, right? Mm-hmm. The flame is something that's independent on its own, right?
Technically it's a combo, right? So if you look at in the guide, you've got part 2.1 is where we mostly focus on each individual trait and its inheritance. And so flame and harlequin, we've been going over the years of they're derived from each other, right? Harlequin was derived from flame, right? It eventually got more and more pattern with the laterals and the belly and the legs.
Higher expression.
It's a stacking. Right. It's our breeding practices over the years.
If you've ever tried to breed those as like, let's say we would try to prove whether it was a single gene, which I did, and it's not. And so it's always a combo of some sort. And so
the flame?
The flame, yeah. So like if you have a white pattern flame, and if you breed an endless line of white pattern flames, you'll get different variations of white, where it's like cream, yellowish, and stuff like that. Yeah. But you'll never produce like a bright orange one from it. I've never been able to produce one. Oh, yeah. If you do orange all the way, you get the same type of thing. Mm-hmm. So now you have these two distinct forms that form, if you were to turn the animal black and white, they're very much the same.
You're fixing it to some degree.
Yeah, but they're still, they behave independently. Yeah. So the best way we've been able to describe, how do you describe a gene that's creating this type of interaction? And so we've been like, well, if we just get rid of Flame and Harlequin, and we just call it WP and OP, it actually works a lot better to describe whether or not you have white pattern and orange pattern, or you can combine the both and you get a tri.
So we talk about epistasis, so you have the pattern, and then is it going to be white or is it going to be orange? Well, there has to be another trait that's affecting it. So if it's in the presence of whatever's creating the pattern, then you get the different colors because you're dealing with multiple traits. So we say OP, WP. Right?
And of course there's, you know, a lot of degrees of how orange it could get or how white it could get.
And so those are all like polygenes. There's tons of other genes
stacking it on top of each other
over the years. We're choosing for how, like, the type of orange, because you can also make yellow-orange pattern, right?
Yeah,
and those are really cool looking animals too.
Yeah.
Reds that they're,
or the red ones, which seem like a new variant almost because it's so like unique and bright and vibrant, and you know, it's one of the only orange patterns that doesn't fade after 5-6 years, right?
Yeah.
If you've been breeding orange pattern back in the day, you know that faded out by that time they were 2 years old, no matter how pretty they were. Yeah. Right? So yeah, that's how it behaves. Two separate little things.
Okay, that's interesting. So as far as, so we know we have orange pattern, white pattern, and when we have a tricolor, we have both. Now, is one dominant over the other? Do we find that orange, or is it just depends on
how you stack it, right? You can have orange stacked more than white, so you get a little bit.
Since they're independent traits, they're not the same, so they're not going to go at the same rate. Right? You're not going to get a 50-50 ratio.
Right.
So it's a dominance fight, and you'll get a phenotype spread because every animal produced from the pair isn't going to have the exact same percentage. So you'll get a range.
Yeah, almost everything you'll start producing a range from it. Absolutely.
Right.
There's always a spectrum for this stuff as well.
Right.
But it's not like a spectrum where, like, you're not breeding it as a trait, you're breeding it as a line. It's a spectrum of how stacked it is over the years, basically. So one that's being stronger than the other kind of thing. Okay.
Now Dalmatians, that's an independent thing completely.
Whole other gene.
Whole other gene, exactly.
Because you can dow anything.
Exactly.
And you can undow anything.
Right? Exactly. But so with the Dalmatians, is it like an incomplete dominant? Like, do we 1 in 4 of our, if we put Dalmatian to Dalmatian, are going to be super Dalmatians? And how could we say this is for sure a super Dalmatian, or is it just up to our judgment? That's how it's been.
It's the stacking thing again.
Yeah. Like, but also, like, how do we use super in the crested hobby? Yeah, right?
I know.
We don't use it like every other, basically, reptile in the entire world. Right? We use the word super in crested to just mean more of insert gene.
But it's also referred to as the homozygous form. So you have the het and the homozygous, which is 1 copy or 2 copies.
Right.
You would think if you just put anything that had a copy of Dalmatian together, you should get a super, but we don't.
Right.
So it's not technically a super. Okay. Super was meant originally in the ball python market. It kind of started.
Right.
Incomplete dominant and 2 copies of the gene. That's what it used. That's what it means.
Yeah.
Right.
But
a super would be the homozygous, 2 copies of that gene to make that. You know,
basically het 1,
but it doesn't.
Homozygous 2.
It doesn't with the Dalmatians.
Right. So it's just stacking of the gene and making it more dominant over time. Yeah. It's a dominance game.
Okay. So how do we distinguish super versus not super Dalmatians?
It's wrong. It's flat out wrong.
It's flat out. It goes in the trash.
We say it in the hobby. We're not saying not to.
We're not saying not to.
The 100 spot.
No, I never want to buy that. I mean, who's going to sit there and call out the spot?
If somebody calls your name, you go, what?
That's
just, that's the spot!
Yeah, that's just like a human definition. You have to have 100 foot. You know, limits on.
I always say, if you have to ask if it's super, it's probably not super.
I say the same thing. When people do that, they'll send me a message, is it super? Does it look super to you? No. There you go. You answered your own question.
Yeah, exactly.
But for Dalmatians, I feel like people have different definition of super. Is it that it's like covered in little spots? Is it super when it has big ink spots? Is it a mixture of both?
That's true, right?
Yeah.
Because some people are like, if they're not big enough. To be called a super, even if it's
littered with little ones.
Yeah, because I've shown pictures of some, and I'll be like, "Oh yeah, super Dalmatian," because it has small spots, but it's everywhere, right? Yeah. And it's the predominant look of the animal. You can tell it's Dalmatian everywhere.
Ooh, a really good one would be the speckling, when they're not actually Dalmatian
that's
spots.
a good point. Some people see freckling on animals as Dalmatian.
But it's not a Dalmatian.
Why,
have you ever heard that before?
No.
Like just freckling, like
so
spots,
little black
scales
all over it. No, little black scales like you'll see on like a yellow is usually.
Okay. I know what you're talking about.
That's tiger.
That's tiger,
being shattered all over the place.
And some people call that Dalmatian spotting,
but it's not.
And I'm
but
like,
it has nothing to do.
That's tiger.
Tigering causes freckling.
Freckling. Okay.
Yeah, not spotting.
It's the
So I call it
trait
freckling.
interaction too, like depending on what you're breeding it to.
Yeah.
And that'll interact with the tiger, causing speckling versus like the stripes on them.
Mm.
So back to your question, what do you call a super Dalmatian? Hell, I don't know.
Whatever you want.
Whatever you want. Honestly, it's just like if.
Don't tell them that.
Me personally, I tell
It
is technically marketing, right? But me, I just say if it's the predominant part of the phenotype, right? Like if you were to list your traits in order of which one was the most prominent one on the animal, if Dalmatian is one of them, where it's like this is massively a Dalmatian, it's covered in spots, it's littered everywhere, I'd say it's a super Dalmatian person. You know. But if
I don't like the term at all, we sort of
he doesn't like it.
It's not.
I just like super.
It's just not.
It's not correct. Yeah, I get what you're saying.
Right?
Yeah, it's Dalmatian, and what?
So you have higher expression Dalmatians and lower expression.
Yeah, so maybe we do that, right?
Yeah.
High expression Dalmatian. That would technically make more sense.
Yeah, exactly.
Yeah.
But
there are supers, like in Crested Gecko genetics, there are supers, like the super caps.
The super caps, super ladies.
But they call them supers for a reason.
Right.
Because,
the correct reason.
Because they named them when they saw the heads. And they jumped the gun and named it and put it out real quick. And then they had that name that was stuck with it. So then when they finally make, the homozygous form, they're like, what do we call it? Because we already named it. So
what if a new gene for Dalmatians pops up, right? That does make a super. What if it's like got a
one
spot, like just like 4 humongous ones, right? Then what do we call it? A super duper Dalmatian? Come on!
We've been over this.
Super duper. That's what I said. I said super duper.
So then
we have a little fun with some of these things.
You have to.
I mean, we can't be too serious about all this.
At the end of the day, we're just breeding geckos. That's what I tell people. We're having fun, and we're
But with this knowledge of how they work. So when we start isolating, which is how I started doing this, to figure it out. When you isolate them and you know what they are, and you really know your animals, then you can intentionally combine certain animals to find a phenotype. It's like designing. Yeah,
exactly. If you have a vision, it's easier to get there if you know what journey, what path to take, right? So as far as incomplete dominance goes, in Crested Geckos, you mentioned cappuccinos, lily whites. What is there anything? Maybe possible sables. We're not sure on those yet.
It's a possible. We're a little early days to be saying for sure. But I think we're working with breeders to try to get better information on it. But once we do, we'll be updating the guide. It's a living guide. So as we learn, you'll see like I have a date on there for whenever I make changes and a revision number just to keep iterating things up. We have a document that can be downloaded and printed. You can mark up whatever you want. The other super that I know of is empty back.
Empty back, right.
Super stripe is not technically correct yet. We're still working on it, but there seems to be for super stripe a heterozygous and a homozygous form, which if you call it recessive, doesn't mean super, because super is supposed to mean incomplete dominant. Empty back, however, does have a super form. And so we have clear hets and clear homozygous forms.
Okay, all right, just so everybody doesn't get lost. So heterozygous just means that it has one copy of the gene. So like a lily white is a heterozygous animal. A super lily white, the one that's not, viable, has a it's a homozygous animal. It's a homo animal, and has 2 copies of that gene. So that's what Anthony's referring to. And recessive would mean that it could have 1 copy of the gene, but you're not going to see it on the animal, right? It's not going to show in the phenotype or in the morph. When you see it, when you look at it, you're not going to see it. So empty back Lily White, Cappuccino are the known incomplete dominants.
Yeah, there's a bunch of them, but
like the one that we could for sure say,
the recent things we're paying attention to, or
that we're paying attention to that, you know, because we're still kind of figuring this stuff out.
Yeah, you can do the same thing. Like for most of the hobby, when people say super, they want to see some like wildly crazy.
Yeah, it's
sometimes.
Yeah.
If you're just starting in cresteds, start looking at other species, and you'll be like, oh, the super form between this and this is not wildly crazy. Like, it didn't just make the animal all black or all white.
Yeah.
So we don't see a lot of it. We don't pay attention that way.
We refuse to recognize it.
Difference.
Yeah, I think is what it is. We refuse to recognize it. Because unless it's wildly crazy, then some people are like, will have a too strong of an opinion on something that needs to be softened a little bit to like really understand how it works, and you see the differences between them.
And in social media, if you do something, you find something, and you try to explain it, you get beat up.
Oh yeah,
it's hard to say something without people having an issue with it.
Yeah,
and you know, it's people wanting it to be theirs, and they don't have it, therefore it's easy to knock.
Yeah,
so we see this a lot in the hobby.
Yeah, I mean,
so it discourages us from exploring these things.
Yeah,
it does. Why would I say anything about it? Why would I continue something that's minimal?
Yeah. Well,
I'm just going to get beat up over it.
I mean, I think it doesn't. I always say, like, the reality is the reality whether people see it or not, you know?
True.
So I think there may be people that want to beat you up, Tom. I don't want to beat you up. I actually love this stuff, and I like that somebody's out there really dialing in on this and making it easier for us to understand it, because it's also going to bring value to all the animals we breed.
Oh, yeah.
You know, because we could tell you specifically, like, you know, not up until last year I was saying I have, you know, this animal's first sale and it's het phantom. Before I wasn't saying that. I was just selling animals that were het phantoms or this, that,
het phantom, het red, same thing.
Yeah, so there's so much that we still that I think the community in particular needs to learn and just start to.
There's a lot in the guide.
Yeah.
This new part of the guide.
Yeah.
With the modes of inheritance.
He kept telling me to stop putting. What are you adding that for? I'm like, because I want to.
Yeah.
I was like, I'm going to keep adding until I get all of it. It's crazy.
But that was a really big reason why we started writing everything down, was kind of get the information out there, because sometimes it's hard to find correct information.
Yes.
Like, that's why there's a collaboration too. It's not that we just wrote it or Tom and I wrote it.
Yeah.
We've actually worked with a lot of breeders that have been working on it for a long time, that have worked on a specific gene or a trait or like something that they saw visually, something that was like small or it could be large. And then they worked on that particular one to kind of get a better understanding of it.
Right.
And that's why we have the information that we do. It's because it was years of work on it.
So, I mean, I started writing it in 2015.
Yeah.
I called it the Crested Gecko Codex.
Yeah.
Oh, that's
something
lost back to that name.
Oh, you like it?
I like that name.
But even like the speckling of the tiger, before we realized what was causing it, it was kind of something that we saw at the shows. We saw it in like just around, and we're like, "What is that? That's so unique. We want to kind of work with that.
Yeah,
what is it?
You got it.
Yeah,
and she's got an eye too for picking the right animals, man.
Yeah.
And I'm like, "You're gonna pick
It's
that
like
one?"
oddities, right?
Yeah.
Like,
all right, hold it back, you know.
Yeah.
And then it comes out, and I'm like, "Oh, look at this animal! This thing's awesome." She's like, "The one you didn't want me to hold back."
But there's like a trait out there that has been around for a long time, and people kind of beat it up, like I said before, for years. Like the soft scale stuff. Like people are like, well, I have that, I have that.
And it's something like we were saying, something so subtle.
But now we see it, right?
That's a good point.
Years
look at the super version. You see it after, like, you make a few of them, and then you're like, these are different. You know, and you're like, wow, look at the difference in the color as it grows. Right?
I had the same problem with hypo. Tried to mention it a decade ago. It wasn't good.
Crazy old Tom.
Keep going at it, and now people are using the term.
Yeah.
You know, we kind of sort of brought it to light a little bit more, but sometimes you have to work on things for years for other people to actually see it, or when they start seeing them in person at the shows.
Yeah.
Remember when you first mentioned it to me, and I was like, did I say that to him? I was on the phone, I was like,
you're like looking back.
I didn't say that to him. Did I say that to him?
Yeah, that's how we started.
Because I was because I've been using this term only in my animals, and but I'm not going to share it with anybody because I'm going to get crucified, right?
Yeah.
And so and when he mentioned it, I was like, did you hear me say that? And I was like, why did you use that term? And I was like, and he's like, because I use it. I was like, bullshit, you use it. I was like, I use that term. When did you? I was like, God damn.
Yeah, here's an article that I wrote.
And then he sent me an article, and I was like, well, technically, I've been using it longer than that. But yeah, you're right. And then I was like, damn it. Yeah, but so he was on the same trail as I was.
I talked to like another bigger breeder like over a decade ago, and he's like, I have this weird red that's kind of light, and I'm like, yeah, it's hypo.
Yeah.
And okay, I thought I had something, and then it was never brought up again and never mentioned again.
So okay, so let's get into the hypos.
If you want to get into the hypos, you'll see it in the guide. Look at the history. That's where I start getting into the hypos.
Okay.
Repashy discusses it in an article, not using the word hypo. We were using cream on cream back then.
Yeah.
Okay.
Cream on cream. And what's AC was doing that.
Yep. And he acquired the same animal that Repashy was discussing. And then so we called it cream on cream in the hobby, right? And then Repashy predicted within a few generations we should make a unicolor animal. And sure enough, we did. And once Caponetto had it, he also used cream on cream. Then he used cream squared.
Yeah.
And then
C2.
C2.
So he started stacking.
Yeah.
So C2. So C2 does not mean citrus. So I do cover that, and on the site you'll see some text that's blue or cyan colored. You can click on that; it'll pop up a link. So you'll see 2 articles that reference cream on cream, C2, and then we eventually transition to hypo as being the better description for it.
So yellow, I see yellow animals because we saw buckskins early on from the wild type. That is what I consider to be like a true hypo, is a yellow. There's different base colors. You have a black base,
right?
You have the red. You have the yellow. Those are your base colors,
right?
So, but the yellows, which is kind of really neat, if you breed yellows and they're yellows, they will always have white pattern. They don't have orange pattern. I've seen a couple, and that turns white very quickly as they start to grow into adulthood. But
you're talking about the hypo yellows?
Yeah, the hypo yellows.
Yellows are hypo. They have hypo in them regardless. It's all over the place.
A hypo animal.
Yeah.
Because of the gene, right? So you've got 2 distinct genes, right? One of them is the yellow base, and then hypo is its own. So like Tom's got cold fusion, which are a particular type of hypo that he's refined, right?
Right.
And then you have like just hypo in general. It's like kind of like all over the hobby, and then you have yellow. So they're all their own sections, right? But yellow is its own hypo trait. It's not like a hypo trait. It's just hypo because it's yellow. It's reduced black melanin pigment in the animal, and it's naturally abundant in the wild. You should be able to see that in the history. So Alan gave me the photos of all the animals from '98 to 2002 that he had recorded and saved, and then I got other slides from Philippe that were collected, and we recorded those into a digital form.
Wow. Okay. And so if let's say I breed a yellow, a hypo, to a phantom, since phantoms are kind of like the opposite, right? They start to enhance the melanin and stuff. So we get, like, I get a lot of, like, I'd like to call them, like, dirty yellow phantoms or whatever.
So here's what it is. You have phantom, which is sort of like a top coat of melanin, on the yellow, which is the buckskin.
Okay.
So you just have that. Yellow on its own doesn't, like, blend. But when you put a phantom trait, it sort of top coats it, so it's different. So if I take a hypo and I'm breeding a hypo black base, which are the blue or grayish tone animals, and I breed it to a yellow with the cold fusion, as an example, when I produce babies, I don't get a blending of the colors. I either get yellows
one or the other,
or I get the blue base.
Okay.
Because considered a black.
Because they're both like 2 different hypos.
Right.
Yeah.
So you have 2. Yeah, it separates.
Right.
So describe the black base when you add hypo then.
Yeah, so with the black base, when I had the cold fusion hypo, it turns blue. If I add lavender, it's got that lavender tone. And if I start breeding in the citrus, it ends up being that grayish as it ages. You get that grayish silvery tone. So so those are the 3 forms that we recognize right now.
So black, once you add hypo, you get your lavenders. Okay. Different versions of how you decide to breed that, will produce like almost like a bluish to a purplish tone. And then his particular tone that he works on is aiming for the blue tone, obviously. And you see that kind of translates over to like yellow animals. So you can add that still to yellow. Okay, so then you get more hypo yellow.
Yeah. So what's awesome is if you take a yellow hypo,
cleaner.
Way cleaner. They're like now the next generation. I have so many animals that are like spotless, no Dalmatian spots. So I'm wondering if there's a correlation to a trait that's somewhere in these animals that could potentially take Dalmatian out and clean up animals. That's how much it's happening now. Yeah, it could be sort of a recessive thing that might be happening in them. It might be probably another trait, but it seems to be
work in progress, obviously. Yeah,
because I'm stacking one trait, but I don't know what else I'm stacking that I'm not seeing. Yeah, so over time it starts to present itself.
Yeah, I think there's still a whole lot of stuff that we don't know.
But yeah,
I've outlined a lot of stuff, right? And then I grouped up with Tom, and we outlined even more stuff, And a lot of my stuff is also in collaboration with like Caponetto and getting information from Alan Philippe and stuff. And so I can't even imagine how much stuff we still don't know. There's still going to be so much out there. Because, I mean, if you look at some of the history, you'll see some stuff in there and you're just like, wait, we had that back then? Yeah, of course we did.
There's a lot of selective breeding and refining too. So that kind of gives us more knowledge on how the traits are interacting with each other and what they're doing once you stack on top of that too.
Yeah, because you can progress each one individually on its own, right? Right. And then back to your phantom, right? So you can add hypo to phantoms and it starts pulling the black back out. I have all white phantoms.
Yeah. Yellow phantoms.
Yeah, I've seen them. I've seen the ones
I've shown them to you. And that's their color fired up and fired down.
Yeah.
I have a couple females, or a female that produced like a whole line of them and fired up, fired down. All you get is a rosy cheek, but it's still, she's white. She's got no melanin to add back in.
Yeah. You know who also has animals like that? Andrew and Sarah Gilpin. They have some really light phantoms that they basically have no melanin.
Right. So I've taken yellows, reds, and blacks so far that the reds you can't even tell they're reds anymore. They're so light. Really? The yellow is almost there to where you can't even tell where they look, especially as they age too. They get even whiter.
Yeah, I'm sure you have some reds that are like, when they're fired down, they're like white. Yeah, right? Yeah. But then they fire it up, you get that red color back in.
Yeah, stuff. So those are hypo reds.
Yeah, for the most part, they're not as dirty, right?
There's hypo in almost everything.
Dirty reds, right?
To some degree, but it might be so minimal we don't see it.
Right.
Yeah.
What is, so you have your cold fusion stuff that you're really dialing in. Yeah. Any other projects that you've been kind of like trying to
because of cold fusion, I've been working it so much, all these other things are stacking. So I'm like trying to figure out the Dalmatian, making clean ones. They're really smooth, like the base color, instead of sort of being sort of jumbled up a little bit. The colors sort of mixed. They're just really smooth looking, solid tone. I'm getting this different scalation that I call SAF. So that smooth scalation refracts the light through it differently. They look really soft. Yeah. It's kind of like a soft scale. We're trying to figure that out still. Right. Yeah, there's a lot to do with that. There are some special animals that popped out that I need to break off from that and do something else with. Yeah, boxes of them.
I saw mine too that you're working on, the knockout.
The knockout? Yeah, that's a black phantom. Yeah. So it's like the charcoal. Charcoal is just a black phantom. Okay. The Pangea OG black line, they're black phantoms. Right. They're homozygous forms. Right. And that, we're seeing that all over the hobby. A lot of people, I have a line, I have a line, I have a line. Yeah. But they're just phantoms, black based.
Now, I have seen, for example, with the cappuccinos, there's a breeder out in Texas. Her name is Janine, and she's been breeding insane cappuccinos to phantoms. And at first, she didn't even know, but those particular animals are jet black. Like there's some of the darkest. Line, right? Yeah. There's some of the darkest cappuccinos I've seen. Black. Yeah, they're nice. So is a cappuccino enhancing that melanin and just making them?
The cappuccino, it's like pulling out a lot of the color here, or the coloration of the laterals, right? And then it fades. Like if you've seen them grow, you'll see the babies are pretty cool. They're vibrant. They look nice.
And they start fading.
And then just as they continue to age, you see that color go away, and then you see the black come out.
But so I've seen that with the orange, because you know the cappuccinos I feel like haven't been as developed.
Yeah.
And I've seen that the orange tends to fade, but I've seen some cappuccinos with the white with the white markings, and they seem to be like not fading. Yeah,
it's interesting because if you think of white, it's not like we're not adding a white color, right? What we're doing is we're taking away melanin. Right. And it sounds like semantics, but it's kind of like a good distinction, because then you can know, you start to understand how the animal actually develops. So if you have like white pattern that grows, then it's literally growing as removing it out.
Color. Yeah, okay.
So it's growing around the animal. Like
is that the same with the lily whites?
Well, yeah, the same thing.
So you get lily whites, you know, that have like a thickness to them, like their markings. How is that? When it's removing the color, is it doing something to that area of the skin?
Yeah,
because some
pulling melanin, continuing to pull melanin. And think about like the colored versions, right? So color is coming from the top layer of the chromatophore. And if you have like, let's say red, for example, you have pure red on an animal, and then what's going to darken or muddy that up is going to be black melanin underneath, right? And if you have a trait that's leucistic, removing melanin, all you are left with is pure red. So you see the purity of the color. That's why you get those vibrant yellows, the vibrant oranges, and the vibrant reds.
With the lilies in particular, vibrant.
So that's another reason that like we say lily is incomplete dominant, not co-dominant.
It's an interaction. You have
it's all over the animal, not patches of lily.
Oh, okay.
Even though it looks like patches to us, we are just misunderstanding.
What's really doing under the hood is it's cleaning everything up.
Everything, yeah. That's why you have a particular red lily that you can't get with a normal red crested.
So, okay, so I have a male, a lily white, a yellow lily male that I've been calling a hypo lily, yellow male, whatever. But because it's just so clean. But it's so, is it not necessarily a hypo? It's just hypo. The lily.
Probably is a hypo. But you're getting into the point of like where we like to say advanced morphs, where
I think we
have so many things stacked.
Yeah.
So they're doing the same.
It's hard to tell whether a trait's there or not sometimes.
Yeah.
Right? Like for example, you mentioned the tuxedo line, right? So you have a black phantom. And then you add cappuccino. Those are some of the hardest phenotypes to discern whether or not it's a phantom cappuccino or whether it's a black phantom, like a really nice black phantom.
Yeah.
Right.
Yeah.
So I usually describe it as overlapping phenotypes, where you can have different genes create nearly the identical phenotype.
Right.
There's some animals that we can't even. Some people can't tell whether they're lily or not. Right.
Right.
Or is it so much white extreme harlequin?
Right.
Some people can't tell when you put that orange all the way up. And is it an orange gecko with tigering?
Oh, okay.
Or is it a harlequin? Is it a black base?
Yeah, when it's like completely covered.
Yeah,
so that's a really good example of that overlapping phenotypes.
Yeah, that's a good point. Yeah, I guess with the tuxedo line, I don't know. I mean, obviously, I haven't seen the geckos in person, but from the pictures,
you're downstairs.
Check them. Well, from the pictures, it's just so like pitch black. I'm like, I don't think I've ever seen a gecko that dark in person. So I was wondering if it was like the cappuccino that was working together.
I think it's adding to it. Yeah. Right. There are pitch black animals. There are some, but they're rare. And I think that when you add another gene to it, it's just going to make it that much
filling
more
in those holes that
easier to make.
And then there's like another trait or something that's going on with scalation. So when you have the right scalation, and it doesn't take the light in and refract it differently like the soft stuff, it makes black look blacker.
You have like soft scales,
it's like a black finish.
Yeah,
so
they're clean. Yeah, they're clean. Yeah.
So we're dealing with multiple things depending on each individual animal. Its phenotype.
Yeah, no, but it's interesting when we start to like strip everything apart and try to like dissect each and everything.
Yeah, that's what I love.
Yeah.
So you isolate.
Yeah.
As far as you can go, and then for recombining, then you know what you have.
Right.
So, like, I know Anthony went through and he's like, I want to put all this stuff in an animal. And so we work completely differently than each other, but when we break down the results of breeding trials, we get the same results.
Right.
Yeah.
So, it's everybody has their method.
Yeah, of course. And everybody has their preference. Yeah.
But
is there anything that you two in particular are dialing in on that you like, one of your favorite projects that you have going?
So many projects
that you could speak of.
Yeah, like Anthony's like, we should, you know, like focus on one thing, and I'm like, I want to do everything.
No, I get
I just want to like have a little bit of everything.
Yeah, we need a warehouse.
How about this? Top two that you guys have. Top two.
Oh.
You get one.
I have my. Oh, I want to.
Oh, I know. Okay, so I'm just gonna say like phantom stuff in general is like really fun to play with for me, especially when you mix with tangerine. So pretty.
Yeah.
And also hypo stuff too. I love the hypo stuff because it just makes everything so clean and vibrant and just. Okay, two things. Hypo.
Two things. You're two things.
I took the two.
You can't just do one.
Mine are probably the combo of the punks and the pandemonium thing that I have. So it's a phantom,
break it down.
hyper tangerine, and I started out.
You kind of cheated there. You're like, all right, two things, but I'm really.
It's in a combo.
There's more.
Find me just one trait.
Yeah, exactly. That's true.
There's got to be at least 3.
But like he said, I like mashing everything together, right, to see what happens, and you get like an insane amount of phenotypes at that point. And then one of my other long-term favorites is still back to the cream on cream.
Mm-hmm.
Okay.
She's just paper white. We fire her up, and she gets little rosy cheeks, the same color white, because there's no melanin there to add to it. So we're pulling her in multiple directions. We produce phantom. Yeah. So we have a couple of things, like if you ever wonder what projects we like doing, we have a little projects page. And we've got like a ton of animals on there, offspring, a group of males, a group of females, but we breed everything 1-to-1 still.
Yeah. Because that's how you got to dial down and what. Yeah.
But so then we break it down, each one, and the different variants and phenotypes that they produce from that group. And you'll see them. We've got like citrus ones, and we have a project Sakura, which is she's all white. That's the one I'm talking about.
Yeah.
And she's got pink rosy cheeks, but she's got black eyes, which is really cool. So it's a white animal, black eyes. And a couple of her offspring, black eyes. Yeah. And I think you talked about it not too long ago, Phantom Eye.
Yeah.
It looks exactly like that.
Mm-hmm.
So it's interesting on a white animal, though.
Yeah, the contrast.
I'm kind of liking where we have Harlequins now, but we're breaking it's like a extreme. There's so much pattern covering the whole thing, but it's like all these little blobs.
Mm-hmm.
And they're all mashed in there. It's almost covering the whole animal. And you just see little lines of black in between them.
It's like somebody went with a paintball gun.
Yeah, so I did like 6 generations through triple X's, and I moved it in a certain direction. So I'm getting these animals. I have one named Duke, which was a couple generations back. But now I have something I call Plague, and it's like all these little blotches like covering the whole side of the animal, and it's heritable. So something's interacting with the pattern to break it differently than the tiger and the pinstripe. There's something else happening, so there's epistasis. There's another trait doing this. So eventually you keep breeding and you outcross and breed back, so you're using the same exact trait, and you're not doing something that looks like it that's out there that might be different. So we isolate that trait, and you keep stacking it by outcrossing and breeding back, or making 6 or 7 lines of it, and then taking one that's been outcrossed 3 ways here and bring it back to like maybe the originating animal to express it more or stack it more. And so I've seen a few things out there, not just what I'm doing. I think it's kind of interesting. It's popping up more and more. As we get more advanced and as time goes by, we're going to start to see new things happen, which we haven't defined.
Yeah, I agree. I'm excited, man. I'm excited for what you guys have done.
What you got? Huh? Come on. What you got? Tell me.
No, I'm also working on a lot of, so I have breeding groups. I haven't been dialing it down to just, a pair. Mm-hmm. So I'm not, I have a lot of animals that I know are hypo, or I know obviously are phantom or whatever, but it's like my genetics haven't been dialed into the point of you guys. But I'm working for Crested Geckos, I'm working with the tangerine stuff. I have some our hypo, I guess they have like a pink coloration base. Mr. Gecko, I call him Majin Buu. He has like a pink,
perfect name.
Yeah, a pink base. Perfect. And he has a tangerine, down the back and stuff.
Oh, really?
Yeah, so
I didn't see that.
I really like that stuff. I also love, I have this animal called Blackjack that's just super clean, really, really dark base, and then the white walling on the sides and stuff.
Yeah, that's clean.
I like a lot of my white walls and stuff, so that's what I got going on, yeah.
I want to see some of those.
Send
those over.
Yeah. We gotta start trading more. Yeah.
Right? Box exchanges is the
One
funnest.
thing that's really cool that's happening right now is people working with tiger. Like I know, like there's different variations of it, but clean tiger is where it's like thick banding, and then getting an extreme harlequin that doesn't have that pinstripe interfering with that. So you're starting to get the tigering and the pattern and color coming over the dorsal.
Like the triple X.
Yeah, so pretty.
Like the triple X's,
And the white pattern version and the orange pattern version of it, the different variations of tigering, I think it's
Yeah,
remember when we were talking about that? And then we were like going back and forth, and I was like, well, if that's possible, then you should be able to make this, which is a white pattern version of this, right? Like when we were going back to WP and OP. And then we walk over to Matt's house, and we're like, oh, it's right freaking there, dang it. And we produced them this season too, and I was like, I mean, this is all holding true still. Like, even things that we discuss and we outline in there, and I'm like, well, I haven't worked on that yet, personally. He's worked on it. So I'm like, well, now we have to collaborate to make sure that this holds true.
Yeah, or he would be like, well, it would have to do this. It would have to produce this phenotype, and I'd be like, here's a picture. Oh, there it is.
There it is.
You know, one shot. So everything in the guide we've described, we've tested all these interactions between us and other people collaborating. But it's like, well, what about this? Well, if it can't do a certain thing or look a certain way, it can't happen. And then he'll send me a picture and I'll be like, okay, it can happen. And he knows what traits he put in his, and I know what traits I put in mine.
Right.
So we went back and forth, and you try to beat each other up and play devil's advocate, basically.
Right.
And that way you're not biased. And we just don't take it personally, and we have fun with beating each other up and make fun of each other, and you know.
But that's the thing too about like the whole thing that we outline is that we found things, or we try to challenge the theory as hard as we could.
You challenge yourself. You're not just
be like, well, if this is true after we've described it in the guide, then we should be able to produce this. And I've never produced this, right? And if he hasn't produced it either, then we lined up a project. This is another reason it took 2 years. For some of the things, we're like, okay, then let's fully prove it. I have animals that I can choose from already in my collection to put together. They're weird pairings, but I can put together to test the theory. And sure enough, over those 2 years, it held true.
It popped up in the phenotype.
You know, some of them I was just like, I mean, yeah, it's not the most fantastic animal, but if it holds a true theory, then I tested this genetically, and it worked out. And then I tested it for another couple generations, and there are even pairings that we've never paired before. But one pairing from that is enough data because I've already paired these two like 10 different ways.
You know your animals.
And so I know my animals' traits. I produce these animals.
Right.
So having that, and you know, I've got like a list of like the genes that I've outlined in each some of the animals, right? So I'm just like, okay, well, this is an easy pairing. This will cross to make this. It's just a new formula that you haven't tested.
It's literally what you guys, it's the foundation. Like you have to break it back down to,
So we take it right back to wild type traits. And then we work from there on how we bred them through the hobby and how they progressed. And then we understand how they work because we're breeding them, we're testing them, and we know our animals. So we understand our trait lineage. We know our lineage, but it only really matters for a couple generations, and then the percentages of what's there gets so low.
Really low.
But when you track your traits, and you know where they came from, and you can identify them and single them out, that's when you can really understand your animals and start designing things. So trait lineage is way more significant than any of the stuff that people are worrying about. Oh, they're naming all these geckos that only their little clique or a few people know.
I trust me. I've known that for a while. I'm like, all right, man, you want to pay this much money because it came from that gecko, but it's not showing any of those traits. Like,
that's a shame. I don't like that. I think
but it's not like I don't think people are doing it like
they're not doing it intentionally.
They just don't understand it yet. You know what I'm saying?
That's it helps clear it up because like if you're the breeder and you now look at like something that you've been selling for a long time, for example, and you've got plenty of history, you've got lineage, you can just go back and start looking at the traits and marking it really quickly. you know, all you have to do is look at the system, and then once you understand it, you can mark everything and be like, oh yeah, this person inherited it, did. Oh, look at the percentages. Yeah. Holy crap, this is working out, you know?
Exactly.
Yeah. So, and if you're breeding something that is phantom or produces phantom, you either know it's a het or a homozygous by how it looks.
Yeah.
And then you know that his babies, you know, if it's a het, it's going to produce 50% possibles in your animals. And then when you know they're possibles, that's when you start to look for, like, is it a het phantom or isn't it? So there's some little signs. So there's an article that's connected with what we just did that I wrote, Finding Phantom, to sort of help people. It's more, to find the hets, but it's more of a guide. Like, if you don't want phantom in your project intentionally, kind of stay away from these sort of things in the animals. So it gives you a little bit of a guide when you're at a show, just for the general person. Yeah. Just because if you definitely don't want it, just stay away from certain things.
What are those things, though? Give me a few.
So if you have an animal that looks like a harlequin, but down the back pattern, you see that darker haze through it?
You're going to have to show me.
Okay, but instead of being the white pattern all the way down, it's sort of in the middle, it sort of darkens, or it's got some orange sort of into it.
So we call them markers.
Potential
markers. They don't always hold true, but they hold true more often.
Yeah, and especially if you're breeding pattern, you know they could be possibly hets. So if you compare your possible hets to your pairing, and you look at all your possible hets, you could probably divide them down the middle and know which ones are going to be het and which ones aren't.
We even have like a phenotype that, like, for me, that I know, like, most of the time it's not going to be het phantom at all. And so we outline that in the guide too. Most of them are like black base, lavender base, pinstripes.
Aside from phantom and the xanthic, is there any other morphs or traits that are recessive?
It looks like the super stripe one is an epistasis, though. That one's a little harder to describe. It's more like so you've got this trait, right? Let's say it's recessive, it's A. It's the epistasis one. You've got another trait, B. If B is present, then express. Okay. Right? If not, then do not express. And would B be pinstripe? For that one, it would be the EB. Possibly.
Empty back?
Yeah. So we're still working that. It's still a work in progress because we have a couple more breeding trials to do. I'm talking to Amanda and Hannah and Kat. So we're going back and forth with it. And then we go, okay, well, I guess we got to breed this to test it out. I have a bunch of animals. Yeah, because there's a lot of Caponetto right now to test that out with. And a lot of them are empty back. We've got a couple of het super stripe and super stripe. And then I have my own super stripes and het super stripes, and then we have empty backs, head empty backs, and super empty backs.
No. So I have,
including the lily forms. So there's a lot to work still, but
early on when we first started discussing this, I'm like, aren't the empty backs the same thing as a super stripe?
That's what
except where you have a different expression of the pin, the white pattern is pushing in more or less, right? So it's either empty back or it's a pinstripe.
But then when you look at the phenotype ratio, which is the animals that you produce and the percentages that you produce over like multiple generations, and Hannah and Wicked and Amanda, they both have a ton of data as well. Caponetto has a bunch, and I have less than both of them, but I still have my data, and all the data lines up. It all matches, and my animals are not. None of them are related. That we're aware of. Right. I mean, if there's a gene, then they're somewhat related somewhere. Right. There must be some ancient ancestor that the gene keeps pushing on because recessive is forever, basically.
But we always start at a point where we like sort of contest something or have personal observations. So we brainstorm. Yeah. Like I literally drive home from work and call them. For a couple of years now, and we just work it out. And we look at examples and we talk to other people in the hobby. And once that information all comes to light, it sort of forms what's really happening.
Yeah, I think collaborating is important. I don't think any one person can just do this by themselves.
And you want to...
It's the best thing. So it's how can you do everything without collaborating? Because there's people out there that specifically breed for a trait.
Like Hannah, super stripes, you know.
And so we saw some stuff in our collection. We talked to her about it, and we're like, but what about this? And even stuff that she didn't see in her collection, we're like, but we've noticed this. And so she went back, took a look at it, and you're like, you're right. So because you can't just do it all by yourself. You have to.
Yeah, you have to
test like your theory or what you see. You have to test it out too. Like, what are you seeing?
Because you might not have a certain gene in your animals that are not, you know, you might have something in your animals that are making a super stripe look a certain way, and then Hannah doesn't have that gene that's not pushing it.
My super stripes look weird, you know, because I put a lot of tiger into them, so they're not as clean as theirs, right? Theirs are beautiful,
right?
You know, they're really clean, sharp lines, right? Mine are jagged and everywhere, and they look wild because I have a lot of tiger in mine. And then I was just like,
so you're separating
tangerine, and then I was like, oh,
you're separating the correlation versus causation because you have these different phenotypes. So you're like, is it this? Is it this? You're guessing. So with all the information from other people coming together, that's when we start streamlining into what it really is, which is your cause.
I even have a hypo C2 one, which is weird because we call him Pinball. And he's like all white, and he's got these 2 super stripes.
But he has freckling.
And he has freckling because he has tiger all over, right? And then it's just this black line down the middle. It's cool.
That's neat.
So but he's totally covered in like white everywhere else. So it's just like, it's very unusual compared to the other super stripes. But that's another thing that you're just like, well, technically, if it's a trait, you should be able to move it into all the phenotypes, right?
Right.
That's what we see.
That's exactly what
it's 100% we see with super stripes. And then when you look at it with empty back, you see the same thing.
Yeah.
You can see it with head empty backs.
Yeah.
All the colors, all the base colors, top coat colors, with hypo, without hypo. I have bright, vibrant yellow ones, right? And then when I add the hypo to it, then that starts to fade out, and you get more of a white animal, right? When I go C2 to it.
And the simple explanation in the end of it is its own individual trait.
Right. Man, I feel like we could just go on for hours and hours about this stuff.
It only took 20 years to write. Of course I can.
I just want the quick, just catch me up real quick. Catch
me up real quick. Yeah, hold on, let me download this to you.
You got 12 hours?
Yeah.
That's why I cut it up into, like, each trait has its own thing. So if anybody wants to just go and be like,
look at their own
I don't care what you're talking about. I just want to know this one gene, so that's fine. It's there.
It's a clickable table of contents. So you can go into table of contents, bam, click on what you want to see.
So Anthony has on his website the Foundation Genetics. Check out their website. Do you have it on your website or no?
I don't have a website.
You your Instagram?
Instagram.
Okay, Geckological.
Geckological, yep.
Okay, you guys want to plug your Instagram and stuff?
What's our Instagram?
lm.reptiles.
Yeah,
there you go.
And then our website is lmreptiles.com.
Yeah, I'll put the links below in the description if you guys want to check out the Foundation Genetics. There's so much good information in there. You have to, start to break it down, especially if you're a breeder, if you want to know what's going on with your animals. This is supposed to be like the basic one, but we kind of got
the basic one.
5 minutes.
No, we got carried away. No, I kind of started trying to be basic, and then we just got into it. But I love it, man. This is awesome, man. Thank you guys so much. I think everybody's gonna really benefit from this, and you guys have done some good work for the community, man. For real.
Thank you.
Thank you, guys.